Hi guys, this is Engineer Jack. Today, mag-orient ako sa structural theory na subject natin. So pag-usapan natin dito yung course overview of the subject and the syllabus. So unahin ko muna ang syllabus ng structural theory guys. So yung course title natin is Structural Theories. Actually, dating dalawang subject siya. Kasi sa old curriculum, meron tayong Structural Theory 1 and Structural Theory 2. Tapos, dalawang SEM siya. Ngayon, pinagsama siya sa isang subject at the same time, isang SEM. Prerequisite natin is the mechanics of deformable bodies or tinatawag natin na strength of materials. So, hindi kayo pwedeng mag-structural theory na hindi papasado sa MEC 3. Yung class schedule natin, more on theories muna tayo. Kaya, 6 hours lecture per week and ikakandak natin as online. 4 units din yung subject natin. Yung term, syempre, ngayong first SEM, year 2020-2021. Yung course description of this subject, this is a professional course common to all civil engineering students, designed to provide fundamental concepts, principles, and theories in the theory of structures and structural analysis for internal actions in a structure and its deformations under load. So yung course coverage natin or yung topic na aaralin nyo within the whole SEM, yung una, the introduction to structural engineering, the analysis and design process, ano bang magkaibahan ng analysis and design, ano bang iba't ibang structural forms, saan ba galing yung loads, nature of loads, and ano bang pwede nating gamitin na materyales in building a structure. Number 2, types of supports, support reactions, degrees of static and kinematic indeterminacy for planar and spatial structures or 2D and 3D structures yan, the degrees of freedom of joint translation or deflection and rotation, conditions of instability, stability, and redundancy of structures. So sa number 2, aaralin natin yan kung paano natin malalaman yung determinacy ng structure natin. Kung determinate ba siya or indeterminate. Kung stable ba siya or unstable. Number 3, syempre, i-review natin yung concepts of axial, shear, torsional, flexural rigidities, and stiffness of structural members. So, yung stiff kasi, it is the ability of the material to resist deformation. Nagkakaroon tayo ng deformation dahil sa mga forces of axial, shear, torsion, flexure, mga ganon. Yung pang-apat, the analysis for external reactions and internal stress resultants of statically determinate structure. Pwedeng beams, plane and space trusses or 2D and 3D trusses, cables and arcs, and plane frames. Mag-solve tayo ng mga determinate structures na yan to solve the external reactions and internal stresses along the members or the structure. Number 5, influence lines for reactions and internal stress resultants due to moving loads for determinate structures pa din. In number 6 natin, these are classical methods of structural analysis for translations or deflections and rotations of statically determinate structure. So we have 6 solutions in solving the deflections. For example, sa beams, we have the double integration method for beams, area moment method for beams and plane frames or 2D frames, conjugate beam method, Castellanos first theorem, unit load method or virtual work, and partial derivative. In number 7 natin, mag-solve naman tayo ng deflections and rotations for statically indeterminate structures naman. So same lang kanina, yung 6 methods natin, same pa rin, yung the double integration method, area moment method, conjugate beam, Castellanos second theorem, unit load method, virtual work, partial derivative. Then yung dagdag dito is the moment distribution method, 3-moment equation for beams, method of consistent deformation or superposition, and slope deflection method or the matrix analysis. Number 8, pag-usapan din natin dito sa structural analysis, yung approximate analysis of structural analysis for statically indeterminate plane frames. So I have 2 solutions, the Portal method and cantilever method. Ginagamit natin ito guys, especially for lateral loads, yung in-apply natin sa structures natin, or horizontal forces. Number 9, or the last topic of our subject, the influence lines for external reactions and internal stress resultants of indeterminate structure. So kung matandaan nyo kanina, yung number 5, influence lines din, kaso nakafocus yun more on determinate structure. Yung course requirements naman natin, course requirements ko sa subject natin sa structural theory, syempre quizzes, the compiled solved problems in structural theory, magbibigay ako sa inyo guys ng reference kung ano bang mga problems ang isolve nyo. Then syempre yung midterm and final examination. These my recommended references, pero may bibigay ako sa inyo guys ng mga reference na mas madali nyo maaral. So you can use the Structural Analysis 8th or 9th edition by R.C. Heveler. And mas maganda sana kung mayroon na kayong libro na National Structural Code of the Philippines. Yung pinaka-latest natin ngayon is NSCP 2015. So, sa lectures, all my lectures are recorded and will be posted to my YouTube channel for you to review. So, ang advantage ito guys, pwede nyo ulit-ulitin i-play yung video and pwede nyo i-download. Yun yung syllabus guys. Ngayon, pupunta naman tayo sa course overview of the subject. So, what is structural analysis? Structural analysis is the determination of effects on physical structures and systems when subjected to loads. So, ano bang effects natin sa physical structures due to loads? So, example of effects, syempre, magkakaroon ng reaction sa supports, magkakaroon din ng internal forces o resultants, pwedeng actual forces, shears, and moments. Syempre, magkakaroon din tayo ng deformations, pwedeng mag-deflect and mag-rotate yung structure natin. Then, meron din tayong example of loads. We have 3 types of loads, yung gravity loads, environmental loads, and lateral loads. Yung gravity loads, meron tayong dead load or the self-weight of the structure. And live loads, transient or the moving loads. Yung dead load natin guys, lahat ng naka-fixed na materials natin sa structure natin, considered as dead load siya. For example, yung mga electrical wires natin, yung plumbing, yung aircon, naka-fixed na sa structure natin, considered as dead load sila. Yung mga moving loads natin or live loads, for example, yung mga tao sa mall or sa bahay, lahat ng moving, lahat ng nagagalaw natin, for example, yung cabinet, yung table, yung chairs, lahat yun live loads. Yung number 2, the environmental loads, we have the rain, snow, and ice. Pero syempre sa Pilipinas, yung kinukonsider lang natin na load, na environmental load, is rain. Kasi wala tayong snow and ice. Yung number 3, lateral loads, which is wind load and earthquake loads. Actually guys, itong dalawang load, environmental loads din siya, pero kinonsider ko as lateral load para naman yan sa structural dynamics natin. So, why do we need structural analysis? So, we need structural analysis in order to design. So, before tayo guys mag-design, kailangan natin i-analyze muna yung structure natin before tayo mag-design. Kasi ano bang ibig sabihin ng design or the structural design? Structural design is the sizing and arrangement of structures and their components to safely support their load demands. So, kailangan natin ng structural analysis guys kasi aalamin natin yung internal stresses, reactions, para alam natin kung ano mararecommend natin na best material, best structure, best component to safely support their load demands. So, where do we start? Siyempre, kailangan natin i-adapt ang basic tools of mechanics. So, number 1 is the equilibrium. Dapat yung entire structure natin should be in equilibrium. Na dapat yung summation of forces natin dapat equal to 0 and summation of moments natin dapat equal din sa 0. Kung mapansin nyo guys, second law of motion ni Newton, kasi pag nagkaroon tayo ng resultant, ibig sabihin magkakaroon din tayo ng acceleration. Na siyempre, pag may acceleration, mayroong movement. Dapat walang movement yung structure natin para safe tayo, di ba? Number 2, the relationship between stress and strain. Kailangan din natin to i-adapt sa structural analysis, especially the modulus of elasticity. Kasi lalo na pag dumating na tayo sa pag-solve ng deflections and rotations. So, gamit na gamit guys yung modulus of elasticity. And yung number 3, the displacement should be continuous along the structure. And that's it. Thank you. So, kung may mga katanungan kayo guys, just comment or you can PM me. And thank you.